Welcome to Mac 2311 for engineers, exam number 4, free response number 4. In this final question, they go ahead and they tell you that your function is equal to this, and they want you to go ahead and find out, let's see, on this interval from 1 to 9, they want to know what is going to be the overall area, and they underline area. So what happens is we actually need to go ahead and break this apart into the positive regions and the negative regions, because we want to go ahead and basically absolute value everything. It's reminiscent of when you're trying to find total distance, not displacement. Displacement, you can go ahead and cancel things out, but total distance, we're trying to go ahead and actually find everything and just add them all up. So what you should do is you should go ahead and say, when is this either 0 or undefined on this interval? You can see it's undefined at 0, which isn't on the interval, so we don't have to worry about that. But you can see it's going to be 0 at 4. So, and 4 is on the interval. So if we can go ahead and mark 4 on this number line here, and then you can go ahead and choose a number above 4 and below 4. And then we can, because what we're doing is we're trying to find out when is this function above the x-axis and below the x-axis, because that'll go ahead and let us anticipate if the area should be positive or negative. So if we can go ahead and choose 2, we choose 5. So if you go ahead and plug that in, well, the bottom's always going to be positive with 2 and 5. But when you plug 2 into here, the top's positive. When you plug 5 in here, you're going to go ahead and get a negative overall. So we should expect that our integral from on this section, on the left-hand side of 4, that should be positive. But our integral should be negative on the other side, on the right side of 4. So what we can do is we can go ahead, first off, simplify this function. And you can see it's going to be 12x to the negative 1/2 minus 3. And then you can go ahead and cancel this out and give you x to the positive 1/2. So we can go ahead and say the area of this is going to be the integral from not 1 to 9, but 1 to 4 of just this function. And then plus the integral from 4 to 9 of the same function. So let's write all that out. Now the only thing is, we know when we go ahead and take the integral of this, it'll come out to be positive because it lies completely above the x-axis. But this guy will come out to be negative. So what we should do is we should really absolute value this integral here, because then we know that's going to give us positive and a positive, and we can actually add up all the area. So if we integrate this, you add 1 to it, divide, so it's going to give you x to the positive 1/2. Then you divide by 1/2, so it's going to actually be multiplied by 2, so you get 24. And over here, you go minus 3, and then you increase by 1, so it's going to give you x to the 3/2. Divide by 3/2 is actually multiplying by 2/3, which cancels out the 3, giving you just a 2 there. So then we want to evaluate from 1 to 4. Now you can see that this is the same as that. So you don't have to go ahead and take the antiderivative of this again. It's going to be the exact same thing. It's just your end bounds change. So you're going to have the exact same thing here, but you're going to want to go ahead and go from 4 to 9. And then that little bit is the exact same thing as over here. So go top minus bottom. When you plug in the top, you're going to get 4 square rooted, which is 2. 2 times 24 is 48. And when you go ahead and plug the 2 into here, you're going to square root it, giving you 2. But 2 cubed is 8, and 2 times 8 is 16. That's your top. Minus, when you plug the 1 in, it just gives you 24 minus 2, which is 22. So then we can go ahead and see that this is going to give you minus 16 and minus 22. That's going to be minus 38. 48 minus 38 is just 10. So what do you know? We got, this is our answer, but this is our value for this integral, and it's positive, and that's what we anticipated. So over here, we can do the exact same thing, top minus bottom, but we want to go ahead and we can just use this guy right here, and it should come out to be negative. We don't even have to worry about plugging the bottom because we've already done that. We said that that was going to give us this number right here. So we only have to do the top part. So you can really, like, you know, save yourself some time and not repeat steps. So if we go ahead and plug the 9 in to this, square root of 9 is 3. So you have 3 times 24. So I'll go ahead and do this over here. You have 3 times 24, and then minus 2. And then once again, when you square root the 9, you go ahead and get 3, and then 3 cubed is 27. So you get 3 times 24 minus 2 times 27, and then minus this expression right here, the 48 minus 16. Okay, so now we just want to go ahead and evaluate what these guys are. 3 times 24, that's going to give you 60, 72. Then 2 times this is going to give you 54. And over here, actually you can run the negative through it, so you get minus 48, and then plus 16. And then what we can do is we can go ahead and combine the positives, so you can go ahead and say that's 88. And combine the negatives, and you can see that's going to be 90, 102. That's going to be minus 102. And when you subtract these guys, you can see it's going to give you negative 14. And once again, this isn't our answer either, but you can see it came out to be negative, which is what we anticipated as well. So with these two numbers, we can go ahead and say, okay, what's the total area, or what is the area itself? You'd say it's going to be 10 plus just 14. You want to absolute value this. So the answer for part A is actually going to give you 24. 24 is the area. But then part B, they go ahead and they actually say that pretend this function represents stock price in the stock market. They want to know what is the net change if X is representing like the number of months that have passed. They want to know what's the net change in a particular stock that this is representing from the first month to the 9th month. So what that means is a net change, that's where you can go ahead and cancel out. You just want to know what is going to be the change in the very end. That's like your displacement and not your total distance. So in that case, you can go ahead and say, oh, I know it's going to be 10 plus the negative 14. You don't want to absolute value this. And you end up just getting a negative 4. So in part B, your stocks actually go down negative 4 units. Okay, so a real quick recap. You can go ahead and say that if this is your function, you can simplify the function first off. You can find out where is this 0 undefined on this interval. We found out there was only 0 at one place, 4. And then you can see that you're actually going to be positive before it and negative after it. So that means that your area should be positive and then negative. You don't need to do that, but it kind of helps out for you to see what's going to be going on. Then we can go ahead and take the antiderivative, which we did, and that's going to be the same in both of these. We just broke it up, 1 to 4 and then 4 to 9. We know this is going to be the positive, so we can just do it like normal, and we end up getting 10. This is going to be the negative, so we're going to work that. We get negative 14, but you're going to want to absolute value that. So that way you can go ahead and add these two areas together to go ahead and get the actual area overall, which gives us 24. Then in part B, they want you to go ahead and actually cancel them out, because they just want to know the net change. They didn't want to know what the total area was. We were actually using this as a representation of the stock market. So these are your two answers, and that's it.